And after college, I got involved in a hackerspace in Baltimore. And what it is a place where people of like-minded interests, usually in technology, could come and work on projects together, learn things, teach things to each other. And it's usually tech-related things, but not always. There's some people who do finger painting there, and some people who do crazy electrical design circuits there, and some people who are doing kind of a combination of both, where they'll do like a sewing and electronics together. And those kinds of projects are always really interesting. 'Cause there's a kind of electronics platform that's designed for circuits for clothing. And it's from Adafruit. It's a company called Adafruit, and it's called the Lilypad. And it's like, you can sew it into clothing, it's removable, a lot of the parts are washable, there's conductive thread that you can sew into clothing and have it, light up, or have have like a conductive part here, and if you touch your chest, then your ears will light up, or that kind of stuff. There's just crazy new things like that. So what's neat about this new digital fabrication technology, which is 3D printing and vinyl cutting and laser cutting and CNC routing, a lot of tools like that. What's neat is you can create products that won't exist in stores, because traditionally to make something you need a million. Like literally, to make a mold for something, they look on how many of these bottles are we going to make, and they make millions of these bottles. But how many Tickle Me Elmos in carbonate do they have? There's just one, but it's really neat and everybody likes it. But it's not something you'd ever see. But if you take this around and try and sell it, like, people like to try to buy it sometimes. I mean, it's not something that I personally sell, but you could make things that only 1,000 people would want, or only 5 people would want. And sometimes going through that, then you might get enough funding to appeal to a broad audience. But things like chairs and doorknobs and cell phone cases and telephones, they're all the same, and there's so many of the same ones. What something like 3D printing allows you to do is customize it. So you can make one of something. The mass customization, which can appeal to broad markets, it's really exciting because different products which would never have existed now can come into play. And I love to tell this story about, there's a fellow I know, and he had 2 cats, and the cats had very specific diets. Well, one of them couldn't eat a certain kind of food, it could only eat the other kind of food. So what he did was he had no way of separating them, and he built a cat feeder that had 2 bowls of cat food and lids, and the lids were motorized so they could slide open. And then on the collars of the cats, he attached an NFC tag, which is a little sticker, and you can give it an identification number. And it's similar to what you see at like if you hear they microchip my dog and they put in a little grain of rice. It's similar to that, but you can put more information in it. You can have that information interact with other NFC readers. So a lot of the new phones today have this chip, it's an NFC reader inside. And you can hold your phone up to somebody else's phone and it'll copy like songs, or you send a picture, that kind of stuff, without emailing. It's just putting it up close. But using that tech is now available to everybody. There's a little thing that's $45 and you can start writing code to these little chips. So he did that. He put an identification number on one cat and another one on the other, and then a sensor in the food dish. So when the cat came up, it would detect which cat and then slide open the right lid for that cat to have that food. And it's a kind of product that, it's awesome, but it's not worth it for PetSmart to take up spot on their shelf for that, because it would cost a lot, because you can't mass manufacture it, because not a million people want it, because most people don't have that problem. So it's neat to have that kind of technology available, and he was able to build it at a hackerspace. And in Baltimore we have a few. There's the Baltimore Node, which I'm a member of, and it's located on 403 East Oliver Street in Mount Vernon. And then there's Hartford Hackerspace. It's on Hartford Road, a little bit north of the city. And then that one's more focused on hardware. So people who are developing hardware are doing more things that you can touch. But yeah, they're there. And the Baltimore node is kind of a mixture of art people and tech people and some programmers, electronics people, 3D printing people. And then there's one by the airport, and that one is called Unallocated Space. And they're in a really neat area. They're like, it's kind of like a commercial storage facility, and they have, you know, like a garage door that opens, and they do barbecue grilling there, and they put in a loft, and they watch movies there and have dance parties. And they also do a lot of programming and a lot of just, I don't know, they made like lights for their parties, and they have, you know, lasers and machines that they built, restored old arcade games and combined them so you could have like 500 or 600 the same arcade game in one cabinet. And those are traditional hackerspaces where it's a membership-based program. The node is a $50 a month place. You can go 24/7 access. You can use the tools there and, you know, share information with the other people there and work on projects there. The Hartford Hackerspace, I think, is the same. I think it's also $50 a month. You get a key and then a vote in the organization. And unallocated, it's a bit of a different structure where to be a key holding member is something like $200 or $250 a month. But then there's other people who are just supporting members, and they're like $40 a month. So you can only go when other people are there. So those are the hackerspaces. And then there's this other group of spaces which are usually tied to universities and things, and they're Fab Labs. And the Fab Lab in Baltimore is at CCBC Catonsville, so Community College of Baltimore County in Catonsville. And they have a program where you have to be a student to go there, but they have conveniently a class set up to learn how to use the machines there. So it's $100, and you're now a student, so you can go. I think it's $100. Or it's $100 for the class, but then you can use it for 2 years. And it's way more organized there, where a hackerspace is kind of just do what you want, don't be a jerk, no open flames, and yeah, clean up after yourself. And beyond that, basically no rules. Whereas at the Fab Lab, it's tied to the university, so first off, you're under all the college rules, and then they don't want you like, you know, running a business out of the space. Whereas at a hackerspace, you can do whatever you wanted. They charge for certain things. It's all regimented and like restricted. But what they do have there is funding. So I know that the budget to open the Fab Lab at CCBC was $400,000, and they've got really nice fancy tables and chairs, and, you know, nice fancy computers and projector screen and like that kind of stuff. And it's all clean cabinets and everything is very organized and stuff. But the hackerspaces are kind of just everybody brings what they have, share your tools with other people, and, you know, just hang out, make projects, open late. The perks of the Fab Lab is they've got like $20,000 laser cutters that you can use, and they don't charge for the machine. They don't charge for time on it. They just charge for materials. So you can bring your own material, and then it's free, and you can laser cut stuff. So this box, the box for Elmo here, I made on the router that they have there. The router is like basically a drill that moves around, so you can control how it cuts. So the side panels got cut, that hole specifically got cut the same shape, all 6 ones on 3 on each side. And then the angles of the boxes and everything. So you could program that on the computer, and then the drill moves around and cuts it out the way you want. You just have to work out how to get, you know, a sheet of 4-bay plywood from Home Depot to the store and to the place and cut it out. You know, the hours are more restrictive. But yeah, so the trade-off is just better machines for rules. And then there's other spaces which aren't as official, like the one at Towson University called the Object Design Lab. And that's also university funded, and it's open only to students of the university in the object design program. It's a place run by Jan Baum, and she has 4 or 5 different 3D printers, and each one manufactures a different way. There's like a powder printer and a wax printer and a printer like the MakerBot that I have in the back of the room there. And they have a laser cutter as well, and a vinyl cutter. So a bunch of tools, but it's like four of the students there. And then at UMBC, there's the Product and Design Lab. It's called the Fab Lab. And at MICA, they have a space also where there's some printers and scanners and things. And so they're mostly open to the students, but like you can talk to them and get in there and use the spaces. And then there's this other program called Tech Shop, which is a more like a Hackerspace and a Fab Lab combined, where it's a membership space. And usually they're $100 a month, and they also have classes there, and big machines. They have a lot of training classes and a lot of different things like that. So they're pretty neat. Yeah, the other cool thing that I've gotten into is these electronic circuit designs, and it's not talked about much in the media. Like, definitely 3D printing is very hyped, but the laser cutters are really cool, and then these custom electronics are cool because while a 3D printer is a machine that can make any shape, any object that you want, there are these little mini computers called Arduinos that can make any electronic circuit that you want. And where you don't have to have all the wires and resistors and components and logic and soldering everything together. You can program on the computer. You can make like this code to do all these random blinks. When they had to make it, with the traditional way, you'd have to have a whole lot of different timers built in. There's a little device called a 555 timer, and it's a little microchip, and you attach capacitors and resistors and to get it to blink to send the right signal the way you want. But with an Arduino, you can write a program and just say, please turn on after 50 seconds and then turn off every 3 seconds. And if this happens, then make that happen. And it's really basic kinds of code that you can write onto a little computer that's that big. So it's extremely revolutionary because you can start designing electronic devices without having to have all the components and solder the circuits and make it all small. And so yeah, the code that runs this is really, really simple, but to build it with analog circuits, which are building it with resistors and capacitors and everything, is a lot more complicated. So that kind of stuff's really neat. And you can use an Arduino to like plug in sensors, and that's how the fella made the thing with the cats. My buddy made one for a Chumby. It's kind of like a tablet. It's a little screen, touch screen. So he took apart a arcade cabinet coin acceptor and connected it to this screen. And it's powered by the Arduino that senses when you put in a quarter and sends the right signals to the Chumby. And what he developed was a bidding system for electronic devices. So, for example, say it's too hot in the room, you can pay more money than the previous person and then use the Chumby and set the temperature. Or stuff for music or for sound, for projectors or anything like that. Yeah, so it's just really neat devices that of course wouldn't exist because who would have that at a store? But the most interesting things come from there. And sometimes really cool devices do get made at Hackerspaces and then turned into commercial products. And one example is the DIY 3D printer market. Like, if you've heard of MakerBot, they started at NYC Resistor Hackerspace, and now they're a multi-million-dollar company from some guys making things. My company also started at the Hackerspace in Baltimore, and now I've been traveling and I sell things that I make. It's a company called Custom 3D Stuff, and I just make lots of 3D printed jewelry and movie prop replicas and custom prototypes for people and CAD designs. So I've had this business that I was able to start by picking a project that I wanted to make and then using the resources at my disposal. So where it's it can be some simple vinyl cut stickers that people can have for their car, up to big scale manufacturing for a large jewelry line, or kits. I sell kits for people to build the full size Han Solo and Carbonite. And I have that. It's all CNC routed, so the big box gets cut in the factory, and I prototyped it at the lab in Catonsville, and then I found a supplier that was able to take the designs that I developed for a ShopBot CNC router, and then they use those same plans at a bigger scale and cut them. And so now it's like every 4 months I'll just say, all right, who wants to buy this kit? And then people put in orders, and then I just type their address into the company over there, and they make it and ship it. So this way to make things without having to do it yourself, it lets you multiply your skills. So instead of a regular jeweler who has to carve each thing, or, I mean, they do mold and cast things, that's a bad example, but for like somebody who's sewing to make a scarf over and over, to be able to like program a robot to do it, you know, you save them a lot of time, so you can have somebody else, you know, or a robot doing the work for you that you design, and then be able to start the next project while it's still going. So that's pretty cool. Yeah, so that was about 20 minutes. If you guys have any questions before I go on, it'd be cool. Yeah. Has anybody here used a 3D printer before this weekend? I like to always ask. But has anybody heard of it before this weekend? Yeah. Okay. Cool. So it's neat to see how that changes. Because every talk that I've been giving over the last few years, you can see like more and more people have heard of it, and then sometimes you see some people who are using it. One of my favorite things about maker culture is that when you make a project, you share it with other people. So there's websites set up where you can document your work and then share the designs and make them open. And what open source means is that the information that you use to develop your designs, your plans, your prototypes, your 3D models, your circuit design, your bill of materials list, everything that you use to make, you share with other people. And what that allows is rapid innovation. And you can fold in the innovation that other people have, you know, discovered, you know, new tricks, a shortcut, or an improvement. You can fold that back into your original design, and that allows multiple people to be working on the same project and develop things faster and faster. And it works great with code, and there's a website called GitHub where people share their code, and then other people, it's called fork it. They basically copy it and make a branch of that code and then keep sharing it and, you know, co-develop things. It's really neat, and some cool things have happened. For me, like one thing, the main things that I make are 3D models, and almost all of the designs that I make I share on a website called Thingiverse. And we were on Thingiverse there's like 50,000 or 60,000 different designs that people made that they share with other people for free. And what's neat about that is that in the future, when more people have machines that can print stuff, or laser cutters that can, you know, cut things out, you don't have to really go to the store anymore. You can just share and download objects, where everybody's used to doing it for movies and music now, where you can download, you know, the album, or somebody can distribute their book without going through a traditional publisher. You can, you know, publish your own ebook yourself online. So that allows more people to produce work and more people to connect to other people and share their work with other fans. So one thing I did is I made a cookie cutter of Natty Bo. It's the logo of the guy from the beer that's made here. And so I made it at a hackathon in Baltimore. And then in DC, somebody was following us and then printed it out. So in 20 minutes, after I designed a Natty Bo cookie cutter, someone in DC printed one out. And you know, it takes more than 20 minutes to drive from Baltimore to DC, so it's literally teleportation where you can send the object from one spot to the other. So that kind of stuff's really neat. At the Baltimore Node Hackerspace, we're open on Thursday nights, and people come and it's open hack. So where it's a membership organization, you need a key to get in during the week. You can always go when other people are there. So people come and learn and teach each other how to make things, and if you have a project that you're working on, you need help with it, or if you want to help someone else with a project, it's a really neat place to go and talk about things. Any more questions? I'm still thinking of other things.
I'm curious about the kinds of machines. So,
Okay.
3D printers and laser cutters, and what other kinds of machines would you find in a space like that?
Okay, so they're always different because it depends which space you're going to and what the people there are making. Like sometimes you see sewing machines and sometimes you don't.
Mm-hmm.
Sometimes you see the 3D printers, the laser cutters, and sometimes you don't. Laser cutter is one of my favorite tools. It's very fast. And the way it works is it uses a CO2 laser to cut wood or acrylic or felt or leather. I mean, the other day I saw somebody take a map of Middle Earth and a piece of leather and put it in a laser cutter, and then it just engraved this map, and he has like a nice real leather map.
Cool.
It's really neat, and it's basically no work. I mean, different places charge different amounts, but I think it's like $1 a minute, or this is like it's typical going rate for $1 a minute, and you know, that map might take like 15 minutes.
Mm-hmm.
So if you took $15 and went to the toy store or to like anywhere online, you wouldn't be able to find a nice leather map of, or I mean, and that's just one example. You can make anything you want there. So the Node has a drill press. We have a bunch of couches and a projector and a speaker system. I have a CNC mill, so it's a 3-axis mill where it's like a little drill bit that's spinning that can move left and right and back and forth and up and down. And what I've used the mill for is to carve a circuit board. So circuit boards are, you always see those little green boards inside electronics, and the way they make them is they'll like start with a piece of fiberglass that's coated with copper, and then carve away the copper with the mill, with the drill bit. So it's carving out the areas that are supposed to be connected from one thing to the next. It'll carve a trace around that. But you can also use it to cut wood, so like a bigger mill can cut things of wood. There's a wood lathe and a metal lathe at the Hackerspace, and most of the things there are owned by people, and they bring it there to share. Trying to think what other machines, and there's like the full tool shop. So like we have wrenches and hammers and that kind of stuff, and table saws and circular saws. One project that we put together for Artscape in 2010, I think it was 2010, we built power tool drag racing. And basically what it was is you took, I mean, the easiest example to explain is if you take a real long extension cord and plug it into a belt sander. The belt sander's got that belt that goes around. And then zip tie down the trigger and then put it down. It just goes. So we made a race, and a bunch of race cars powered by power tools. So you can get a circular saw, an angle grinder, and a Dremel, and there's safety precautions and stuff set up for like a track for it to go down. But so we set this up at Artscape, and people built like little go-kart things, little machines, and it was really neat. And then we do different festivals like Robot Fest, which takes place, I think it's early summer, late spring, at the National Electronics Museum by the airport. And
you got a flea market there next Saturday.
Yeah, great. It's like a techno swap fest. Yeah. So we set up a booth there. One of the projects we built is a rocket launcher for kids, and it's a solenoid valve attached to a button and an air pressure tank. So when you hit the button, the valve opens and it lets some of the air out of the tank. It runs through the pipes that we built that blow this construction paper cardboard tube built rocket really high in the air. So the kids love it because they gather around and they're building their own rocket, and then they hit the button and it goes really high. It's really fun. And so that's a really cool starting project. And one of the projects I like is spin art. I used that when I was a kid, and people would have like little kits. But Harvard Hackerspace built, I think it was Harvard Hackerspace, maybe Unallocated Space. One of the other two in town, they built. It took like an old washing machine motor, and it spins a nice big piece of paper around. You can make giant spin art. So they do that at festivals. And one thing they built also was a fire tornado, and that's one of the coolest devices.
I think I've seen that on YouTube or something.
Yeah, it got really popular. You take 12 box fans, and you point them all at a barrel of fire. and then you turn the box fan slightly, so you're creating like a wind tunnel. And then when the fire and the fans and the air all go together, you get a pillar of fire going up in the air that spins around, and it's quite literally a fire tornado. So they set these up in at night at their space outside. It's just really cool times. It looks really, really neat. But there's also maker fairs. Maker fairs, they take place in a bunch of different cities, and Robot Fest is sometimes it's mini maker fair, and what is a place where people who have created objects will come and show. It's kind of like a show and tell. Not really a science fair where they're trying to prove something, but it's just, hey, I made this awesome Power Wheels racer, and I enhanced it so it goes really fast. So they have Power Wheel racing series there, and a bunch of people from all over the area build these kind of like drag racers, and they go around courses and stuff. And they have I don't know, there's just so many cool things. One of my favorite projects I saw last year at Maker Faire was the hammock car, where a guy built a hammock that was mobile. And he had a joystick, and he was riding around the whole place in a hammock. Just, again, a product that's you're not going to find at Home Depot or Walmart. But, it's not so much to build. It's not so hard. So if you go to a Fab Lab and you're like, I really want to build a hammock car, nobody will build it for you, but they'll like, oh, you probably need a motor. Where'd I get a motor? Oh, let's look for one. Oh, you need to control it somehow. How does the joystick work? And then you take it apart and see how it works. And, oh, I don't need this feature. Or I wish I had this feature. That's really neat. And another project I worked on recently was I went to this space at NYU's ITP program, and it was called Hacking for the Holidays. And what we did was we brought toys that we got from Walmart or CVS or wherever, and took them apart. And people with severe physical handicaps that couldn't use a joystick or thumb controllers, but could use like giant button switches or like a head switch. So we took apart the toys and changed them and added these little adapters so that the regular Mustang remote control car that has the complex controls was then controlled by the 2-button controller that they make for 2 or 3-year-old remote control trains, where it like goes either forward or back and turning, and then it was able to connect to the big sensors that the kids were used to. So that was just a really neat project. And then a couple of hackathons that we've done in the area are it's basically they lock you in a building for the weekend and you just work really late. Red Bull often brings lots of sodas for you guys to drink, and you just stay up really late and either start businesses or work on a particular project. So we did one at the Digital Harbor High, and it was education hackathon, and a lot of people developed either short little simple programs or little businesses or little small applications or devices that you build it in a weekend with people that either you never met before or that you've never worked with before on a Friday night, and then Sunday you're presenting it to investors. And a lot of people like the shows like Shark Tank, but you can get involved and do it yourself, and you just go to these startup weekends and hackathons. And I did one recently at the Walters Art Museum, and we scanned we used a 3D scanner and scanned a whole lot of the artwork there, a lot of the sculptures, and some of them were damaged. They needed to be repaired, like a nose was missing off one of them. So one of the things you can do is you can scan your nose and then scan the sculpture and just drag and drop your face onto a piece of art. And then some where there's like a big crack in the skull, and you could fix that, or a lot of things. So we did that, and one of the project was to print out smaller versions of the artwork that blind people could then touch. Because if you're blind, museums have to be really boring. They don't even let you touch anything there. And to be able to open up this world of artwork to people who can't otherwise experience it, it's really neat. And definitely get involved in hackathons or Fab Labs, or I think the Hackerspaces are the best way to go, because there's so many people there, they're open way later, and it's like a better way to tinker with things. Instead of just going home and watching TV, you can go and fix a TV. And it sounds like, well, why would I want to do that? But to take something apart and figure out how it works. And in today's society, when you have so many people throwing out televisions, you can take them apart and fix them. Or I know in Europe they have these repair cafes that are starting, and people bring in their broken toaster and they leave it there, and then someone else, for fun, will take it apart and fix it and play with it and sell it back to the person, or that kind of stuff, or give it back, or that kind of thing. So it's really neat. Yeah, but just learning how stuff works, taking stuff apart, changing it a little bit, and then people make pretty cool devices. Like a guy I know, Jimmy Rogers, he makes a bunch of lights. It's like it's a heart, and it's a whole bunch of lights. He was able to develop this board that he sells these kits, and people can solder together a little heart that clips on and it lights up and beats, and it can clip onto one of the Arduinos and it'll light up that way. He made a little screen, a very low resolution screen that he wears as a belt buckle. So he makes these kits, and now he sells those kits. And there's a guy, so a really famous hacker that started Noise Bridge. It's the first hackerspace. It's in San Francisco, and it's Mitch Altman. He made the TV Be Gone, and he was addicted to television. He would watch it like 8 or 10 hours a day, and that was his life. He'd work, he'd come home, and he'd just watch TV, and that's it. And a lot of people in America are like that. It's a serious addiction. It's like he always says those people on TV are not your friends, and people get into that when they're like watching all the shows, everything, and then the reruns and everything, and just really kind of wasting their lives sitting there. So he disliked that. He stopped watching TV at home, and then he found himself out at restaurants and bars and hotel lobbies where there's just TVs on, sitting there, not being watched by anyone but polluting the airways. And so he developed a device called the TV Be Gone, and he did this at Noise Bridge, and now he sells these kits, and it's just, you can solder it together yourself, or you can buy a fully assembled one, and you push the button, and it turns off the TVs. It just goes through all the TV off codes for every TV, and it's sorted to send the right code to the top of the list, so the more common TVs are listed first. And it just it turns off TVs. It's there's really neat products that are available that you guys can make, and if you want, you can just learn one skill. Like, first, I don't know how to solder, so I went and learned this is how you solder. So then you take the next step, and you're like, well, I want to, build something now that I can solder. So instead of just soldering 2 lights together so it blinks, you can make, 10 lights or a lot of things. So like recently, these guys from, I think they're from Leica, but they're building a movie. They're filming it yesterday and this upcoming week, and they ran a Kickstarter campaign to raise money to film the movie, and they needed a prop for the movie, and they contacted the mailing list for the Baltimore node, and they said, can anybody make this visor for us? And they provided concept art. So I made the 3D model of the visor, and then printed it out, and I had little spots for where the LEDs would go, and they told me how they wanted the program for the lights to run, so it blinks the way they want. And basically it was a 3 or 4 day project where I modeled and printed and sanded and polished, and then designed the electronic circuit, and I just combined those skills of 3D modeling and electronics, and you got a device that you could use in the film industry. And yeah, so that was just a really neat project. Yeah, we have about 15 more minutes, so I don't know if anybody has more questions. Yeah, go ahead.
Are the copyright owners concerned about this, like the map of Middle Earth or Hand-Sullivan Carbonite, or they know about this? Are they okay with it?
Yeah, well, a lot of times either it's looked over because the scale is way too low. Yeah, if the scale's small enough, often they either don't care or aren't interested or don't know about it. A lot of times it's not infringing on copyright, so a lot of people sometimes think certain things are and aren't. So there's a big misconception on what's covered under patent and copyright, trademark, and what those terms even mean. So I mean, through specific instances, I've had to learn the differences, because I have gotten a cease and desist letter for one of the projects that I worked on, and sometimes things that people think are covered under certain rules aren't, and sometimes they are. And it's definitely neat. But like, for example, this piece here, it's something that would be, because it's a new creation. It's, parody, mash up different things. It's different than me just, selling an exact replica of, Elmo. It's, different when you have, a piece of artwork for a certain thing versus, just directly selling other things. So there's a lot to it. But yeah, it's pretty neat. But definitely scary. But definitely the cool applications of the technology is not recreating things that you could make other ways just to make a buck. It's the new projects, the new things that you can make, like the Dream Machine or the Bug Assault or the the visor for the movies. Like this one guy made a weapon that's pump action powered that shoots salt at bugs instead of a fly swatter, just because he could. And a guy I know who's here in Baltimore, he goes to UMBC for school, but as a hobby he modifies Nerf guns just to be able to shoot 10 times as far or 10 times as strong, and he changes these and takes them apart just because it's neat to be able to take things apart and change them to make them the way you want, and that's really empowering versus going to the store just to buy that next thing. So it's really neat. So also recently I went to this rec center in Baltimore, and it was like a rundown rec center that the city owned and reopened through the help of the Digital Harbor Foundation as a tech center where kids can come and learn the new technology skills. So they have a 3D printer there and a vinyl cutter there and a bunch of computers. And the way the program's set up is that kids can go after school to learn these new skills, and it shows them like that what you can learn, that knowledge and information can translate into money and translate into better futures. So the center's open, people can go there and learn how to build a website. And I mean, how many people here know how to make a website? A few, but not everybody. So what happens is the kids can go and learn and then sell websites to people who need. So people who come and say, hey, I need this website, they can start earning money for their college education. And it's neat to see that knowledge can translate into a better future, where a lot of times people in school don't realize that. It's like, why am I learning this? What is it for? But when you can directly turn something that you learned into money, into your future. So I mean, it's really neat. It's a really neat application, and I don't know. It's pretty cool. Yeah. Anything else? Well, yeah, I can keep talking. Yeah, definitely come by the booth in the back. What I've been doing is, I worked at MakerBot all last year as a 3D designer, and before that, I worked for myself running a company called Custom 3D Stuff, where I just made things, a lot of different jewelry pieces and replicas and custom things for people to sell online. And before that, I was a traditional engineer in 9 to 5 or regular kind of job, and it was I don't know, it's a lot more fulfilling to be able to make stuff yourself and live off that. So it's been pretty cool. Yeah, what else? The Lilypad LEDs are really cool. They're these, it's like a power pack and a little, it's like a disc with holes in it, and you can sew it into clothing. So I think definitely in the future you'll start seeing a lot more fashion and dresses, shirts and things with legs. You've seen like the start of it with those T-shirts that people wear to like dance clubs sometimes that have the mixers they light up. It's kind of neat, but it's just like the start, just the lights. Like one of the coolest projects I saw recently. I met a fellow at the Hackerspace in New York, and he was sewing LEDs into his pants. And he also sewed an accelerometer to his pants. So when he moved to the right, the accelerometer would pick it up, and the LEDs would turn red. And when he moved to the left, the accelerometer would notice, and his pants would turn blue. So depending on like the way he walked and the way he was dancing, he would like light up different ways. And it was really neat. And there's there's a cool video of a snowboarder who built a whole snowsuit that was covered in LEDs. So he's snowing pitch black at night, but he's lit up and he's doing tricks and stuff. So that's really neat. And one thing I saw somebody make was a typewriter that was powered by a computer. So you could give it a script, like a text file, and then it had little valves that would pull down on each key, and it would just type by itself like the player piano, but for a typewriter. So people just build these kind of things just because it's neat and fun and crazy and just really cool to do.
We reinvented the teletype.
Yeah. And somebody made a fake fire in a log. So he milled out a spot in a log and then put in an old lamp, old lights. So the lights would flicker, but it's like inside a log. It has a switch on the side of a log. They're building this like crazy garden thing in the Hackerspace in New York, where it's like a rotating garden system, so it can keep all of your, if you're growing herbs and plants or whatever, like in a small space, and it spins around, and it strengthens them because they keep like turning towards the light and away from the light as it spins around, so it makes them even stronger. And, I don't know, there's so many different cool projects that people are making. It's just like way more exciting than just like, sitting at home and living like normal, regular people lives, where you can see all these other projects that people are making.
You're talking about jewelry, and I've heard that recently, that there are some 3D printers that will work in metal. What kind of metals are they working with now?
Yeah, a lot of the jewelry that I have in the back is all 3D printed. Or all the jewelry I have in the back is all printed. It's there's a machine. There's a company called the X1 Company, and one of the things they manufacture is metal printing machines. There's a couple companies that do it, but the ones that work there it's 60% stainless steel and 40% bronze. So the method works by like an inkjet printer coming and squirting out glue onto stainless steel powder, and then it binds together the powder. And then a roller comes by and brushes a new layer of the powder on top. And the print head glues them together. So what you're left with is a glued together, 60% solid, 40% glue metal piece. And they put that in the oven with bronze. And they heat it up really hot, and then the bronze liquefies and the glue melts away, and then capillary action draws the liquid bronze up between the steel particles. And you have a 100% solid metal part at the end, where it's like it's a matrix material of 60% steel and 40% bronze. But you can start with different materials. You can do it in different methods. And then another way to do it is to print in wax, and then use the wax as investment. So you print the wax, and then they put it in kind of like plaster material, and then put that in the kiln, and the plaster gets solid, and the wax melts away, and you pour out the wax that's left, and you're left with a cavity of the shape, and then they can pour in the precious metals right into that. There's one where a laser does the same kind of thing as the first method, where it's sintering the metal powder together. You get metal parts.
The reason I asked about that is I'm in the antique car hobby, and every now and then you'll come across a very rare car, and it's got some part missing, and you just cannot find that part anywhere. But if you've got pictures of it,
if you have
and
pictures,
you can convert those into a 3D model, printing out that part. And we had figured before, you could do this, print out a wax model and do an investment casting, and then I came across, oh, wait a minute, you can do it directly in metal?
Yeah, direct metal printing is expensive, but one other thing you can do is print it in ABS plastic, and ABS and PLA plastics burn out as well, and it's way cheaper to do it that way. So you can take the photographs and have somebody do CAD design for you to create the 3D models from the photographs, or you can 3D scan the part if you have one, and then you get the recreation that way, or you can directly mold off the original.
Yeah. If you got the part in hand, you can just make the silicone mold and make it. But sometimes you just got a picture.
Just pictures sometimes are enough to create a model automatically. So that's what we did at the Met. We went there with just a bunch of cameras. I used my cell phone camera and scanned a lot of the sculptures there. You just need like 40 or 50 pictures. Sometimes I've seen as low as 13 different photos, and the information is enough for a process called Photogrammetry, and it just assembles the model of the part. I mean, it might not be accurate enough for a mechanical part. You still might need like laser scanners for that, but for artwork and for people and things that don't need to fit together, that don't need tolerance and stuff. Photogrammetry is enough. And I've also brought a handheld 3D scanner here, so I've been scanning and printing busts of people all weekend. So you can come back in the back and see those. They're pretty cool. Yeah. That's. I mean, really only the tip of the iceberg. There's so many more things to see and do at the Hackerspaces. So definitely check out if you're not from the Baltimore area. I think Hackerspaces.org has a list of thousands of different spaces around the world. There's about 400 different Fab Labs, and just the Hackerspaces. They're all over, and often in different areas. They're different, based on what people are working on there. But there's always cool things. So I mean, I don't know where everybody's from, but definitely check out in your area, and if not, start one.
So I know that there's a new Fab Lab starting up in DC.
Yeah, there's at least one in DC. Yeah, I met the lady who's running it. I think at the time it wasn't open to everyone, so it's not just you can sign up. She only had like 6 or 8 people there.
Yeah.
It's like part of it, but yeah, Fab Lab was started by Neil Gershenfeld at MIT, and the whole premise behind it is that they all have the same kinds of machines, so that anybody can go and use them, and they're easy to learn, safe kinds of machines that people can just make. And there's a charter online, people could follow it, and it shows like how to run a Fab Lab, and a lot of the tools there you can make with the tools that are there, so it's pretty neat. Yeah.
I think that initially I came into this with a question is, when people go to use a space like this, are they doing it because it makes more sense to share the tools than for each individual to have all those tools themselves?
I mean, that is a huge part of it.
Sometimes you wouldn't have space for it anyway.
They're still
Or
expensive.
do you do it for the community?
Yeah, I mean, it's a huge part that, like, I'm not using my hammer all the time, so why not share it with the people who need the hammer? But it's so much more beyond that, where you have the community of people who are there, sharing information, working on projects together, and teaching other people, and, even just hanging out, and, like, it's some really cool stuff, and really interesting people that you meet there, and, yeah, the one couple that joined, a couple years ago, Rob and Danny, they came in and they said, well, because we have a cohabitation discount, so 2 people, if they live together, they can pay $75 total instead of $100 for the joint membership. And what they then do is come there instead of television directly, because for $75 they decided, well, let's cancel TV and do this instead. So, and the benefits are way beyond. One of the cool kinds of things, I guess I'll close with this, is the lock picking community. A lot of them come to Hackerspaces, and it's really fun to learn how locks work and learn how the security systems work and play with them and learn about them. So, a couple years ago, one of the gifts, like Rob and Danny, they gave each other sets of lock picks and practice locks. And then one of the things that Rob gave Danny was a locked box with no key, and inside the box was a gift. So it was, you had to play with it. And Locksport, they have like competitions, and it's really fun to play with it and like learn how it's working and without malicious intent. Just I want to try and get the lock open because it's a fun thing to do. And it's just fun. So I'm not sure if she ever got it open. I got it open for her, but didn't show her what was in it. But it was pretty fun times. And it just really encourage you to get involved and start making things that you need, and not relying so much on buying things. It's fun and also helpful. You meet great people and have great times. Yeah, thanks everybody for coming.
Yay, thank you.